In this video, I'm just going to derive the first two Suvat equations, and then we're going to use those in the next video to derive two other Suvat equations that you'll come into contact with during your Unit 2 work. To do this, I just need to set up a little graph, a velocity time graph, just to show you graphically and also algebraically how these are derived. So I'm just going to set up a little axes, a y and an x, and on my y, I'm going to have velocity, so it's going to be a velocity time graph. So velocity on the y-axis, and I'm going to have time in seconds on the x. Now, if I'm going to draw a straight line, we can obviously see that increasing velocity in equal amounts in time, it would be constant acceleration. I'm just going to take 2 points on this line, and I'm going to take this point here, and I'm going to denote that as u. So I'm going to mark that off as u, meters per second. And in that time frame, I'm going to, time frame of t, I'm going to record by which time this object or particle has increased its velocity to v. Now, obviously, the line indicates acceleration, it's constant acceleration. So what we can do is actually calculate acceleration. Now, if we were given values here, i.e. numbers, we could do that by just changing speed over changing time. But here we're using variables, so we can set up a general case. And to calculate acceleration, as I've said, it would be the change in speed over change in time. Well, we would obviously do our faster speed, which is velocity, which is v. Take away u, that would give me my change in velocity, and my time I've set as being t. Now, obviously, that's technically a Suvat equation, but it's not really particularly nice to look at. So the first thing I would do is actually multiply through by t. So that would give me at is equal to v minus u. And again, it could be classed as a Suvat equation, but to get it to the form that's recognised in mathematics, I'm going to add u to both sides. So I'm going to end up with v is equal to u plus at. Now that is our first Suvat equation, v equals u plus at. Something else that we can do with our velocity time graph, and this comes from GCSE, is that the area under a velocity time graph in a set period of time is the distance travelled or displacement. So what I'm going to do now is I'm going to find the area under this graph between u and v. And actually, as you can see, it's a trapezium. Obviously, we've got our straight line, which is our constant acceleration over a time t. So basically, I'm going to use my rule for finding the area of a trapezium to find the area under this graph in a general case. So if you remember, area of a trapezium is the sum of the parallel lines divided by 2, multiplied by the distance between them. And in this case, our parallel lines are the two vertical lines. So my displacement is going to be the sum of my parallel lines, which is u plus v, divided by 2, and then times by the distance between them, which is t. And that actually is our second Suvat equation. S equals u, please.